Hello there, my name is Abel Tamina from HMT Academy. So before we begin, please subscribe to the YouTube channel and click the notification button that every time we post a video you can be notified. So today I would like us to look at the 4 set operations that are used in set theory. The 4 set operations that are used in set theory. So the first set operation that we use in set theory is called the union. The union represents the combination of 2 or more sets, and the elements don't actually repeat. So you can have set A, set B, and set C. If you have union, it implies that you are combining the elements in set A and the elements in set B and the elements in set C, but those elements shouldn't repeat. So showing this on the Venn diagram would actually look like this. Suppose that's our Venn diagram. Then we have set A, then we have set B, then we have set C. So the shaded region there is the union of set A, set B, and set C, and we represent it like that: set B and set C. So when listing the element, ensure that they don't repeat. The second set operation that we can look at is called the intersection. So the intersection of 2 sets implies that you have members that belong to those sets that you are looking at. So if your focus is on set A and set B, it means the intersection of set A and set B is simply the elements that are found in set A and are also found in set B. For example, set A comprises of 1, 2, and 3, and set B comprises of 2, 4, and 6. So it means that the intersection of set A and set B, represented by that symbol, would actually be 2 only. So 2 will be the intersection for set A and set B, because 2 belongs to set A and also belongs to set B. The third set operation that we can look at is called the complement. So the complement of a set means that we are looking at the members that are not part of a specific set, but are actually part of the universal set. So the complement is represented by a prime or power C. So if you have a complement, it can be written like that, or it can be written like that. So either ways, it's still complement. So if you have the complement of set A, it implies that you are looking at the members of the universal set which are not part of A. So if you are to show that on a Venn diagram, suppose I set A there, just have one set, and that's the universal set. So the complement of set A would actually be that shaded region. Then the last set operation is called the difference. So the difference is actually similar to the one that we are just from looking at. So the difference of a set is represented by, suppose you have A minus B. So if you have A minus B, that's the difference, because difference means you're subtracting. Difference, the answer that we get after subtracting, of course. So we have A minus B. A minus B implies that we are looking at the elements that are in A and the elements that are also part of B, and those elements that are in A and in B are subtracted from A. So in short, we have all elements in A and we are subtracting from A those elements that also belong to set B. So this can also be written as A intersection B complement, meaning that we are removing the elements that are in B which are also part of set A.